For today, we have an essential question. It's number 4 out of 4 total. This will be our last essential question for this particular section. Today, can evolution be observed today? The essential question for today, can evolution be observed today? This will be our last essential question under the topic, evidence for evolution. This will be our last essential question under the topic, evidence for evolution. For our first left-hand column, our only left-hand column today, we have evolution today. Evolution today. The traditional idea that evolution is a very slow process that can only be inferred from other evidence and cannot be observed in human timescales is inaccurate. Natural selection is an ongoing process that occurs in all populations. Since natural selection is one driving force behind evolution, it makes sense that evolutionary processes are readily observable in nature and man-made systems. Evolution has been observed in a wide variety of studies, perhaps the most famous of which was work conducted on the Galapagos medium ground finch. Observations of this bird, made over a few decades on one of the islands in the archipelago, has shown that within the population, the size of its beak changes in response to competition with other bird species and fluctuates dramatically in response to changing climate. Evolution is most rapid and therefore most readily observed in populations of organisms with short life cycles and high rates of reproduction. Bacteria fit this description particularly well and provide many examples of evolution in action. One of these is the evolution of the bacterium Mycobacterium tuberculosis, which causes the disease tuberculosis, aka TB. Historically, TB has been a major cause of early death in people. In the middle of the last century, a new class of drugs called antibiotics was introduced to combat this disease. These drugs were initially very effective at curing the disease, but after about 30 years, doctors began to notice that drugs that were once effective no longer worked. In many countries, the disease began to make a major comeback so that by 1993, the World Health Organization declared TB a global health emergency. Again, the bacterium Mycobacterium tuberculosis had evolved. It had become resistant to a number of antibiotics, and this resistance was traced to a small substitution mutation in one gene. Once the mutation had occurred, it spread quickly throughout the Mycobacterium tuberculosis population, and in recent years, other disease organisms have shown similar resistance to what were once effective treatments. The treatment of tuberculosis is just one example as to how human activities can unintentionally create selection pressures that drive evolution. Another example is trophy hunting. Hunters deliberately select animals that are in peak condition. Deer, for example, are often selected for their magnificent antlers. Hunters select the largest and healthiest bighorn rams to shoot. In both cases, this has led to a reduction in the individual size and headgear. In Africa, poaching for ivory has produced some populations with high numbers of elephants with no or very little tusks. In North America, selection of the largest Kodiak bears by hunters has produced a decline in the average size of bears within the population. Similar changes have been observed in fish stocks. Nets select fish above a certain size, so some species have evolved by reducing their size and breeding at a younger age than they used to.
To understand how mutations can result in evolutionary changes, let us look at a simple example that occurs quite frequently in bacteria. If a large number of bacteria are treated with the antibiotic penicillin, the drug typically will kill most but not all of the organisms. This is because out of a population of billions of bacteria, there is almost always one that is mutated in such a way that penicillin will not kill it. Since bacteria reproduce very rapidly, a new population that is said to be penicillin resistant will develop from the mutated organism. Penicillin works by blocking the active site of a certain enzyme needed to make the outer protective bacterial cell wall, for without their cell walls, bacteria die. Looking more closely, we discovered that the new strain of bacteria have developed resistance to penicillin because a substitution mutation exists in the gene for the cell wall enzyme. The code word AAC for the amino acid leucine has been changed by just one letter to ACC, the code word for the amino acid tryptophan. The new amino acid changes the enzyme's active site so that penicillin can no longer block it. As a result of the mutation, the enzyme can assist in carrying out the chemical reaction for the cell wall, and penicillin will have no effect on it. In the natural world, bacteria and penicillin-producing fungi compete for the same food supplies, so being penicillin resistant gives the mutated bacteria a big evolutionary advantage over the normal bacteria. In the presence of the fungi, the mutated bacteria will have free access to the food supply and be able to reproduce, while the normal bacteria will be killed off. This is a simple example of how in nature, new species of organisms can develop over time, according to the evolutionary process called the survival of the fittest, in which the organisms with traits best suited for a certain environment thrive and reproduce, while those with less desirable traits struggle to compete and die out.
That will do it for today's lecture. At this point, you should be able to write a response to today's essential question. Can evolution be observed today? At this point, please pause the video and write your response to today's essential question in the summary box at the bottom of your notes now.